Okay, we are reviewing inverses basically, but don't forget about compositions, right? There's no compositions on this or decompositions, but don't forget about that. Okay, your compositions. Okay, number 1 says find f to the minus 1, which you need to know means f inverse, right? So we're finding the inverse of a function. Say when we do an inverse, we switch the x and the y. So this is technically y, right? F of x means y. So we start off with x equals 4y over 2y minus 3. We switch our x and our y, and now we have to solve for y. So we're going to multiply by the denominator, right? Because I don't want denominators. They're icky and gross. So I multiply to get rid of my denominator. And on the left side, I'm going to now distribute. So 2x times y minus 3 times x equals 4y. And I notice there are 2 y's in my equation, and they're not together. So my next job is to get the y's on the same side. So I'm going to subtract 4y to the left. And at the same time, I'm going to move my 3x over here. So I'm going to add 3x to the right side. So my equation now looks like this. 2 times x times y, or 2xy, minus 4y equals 3x. So hopefully you notice, like I do, I have a y on this term and a y on that term. And the way I can take my 2 y's and change them into 1 is by factoring that y out of both of my terms. So I have a 2x that's left over and a minus 4 that's left over when I factor that y out of my equation. And that equals 3x. So my last step is to divide by 2x minus 4. So my final answer, 3x divided by 2x minus 4, and I change my y to be a y inverse, or in this case, f inverse, since these two things are synonymous, right? But make sure you are including the inverse notation to differentiate between our answer, which is new, and our beginning, which is old. Okay, so we use that notation of f inverse to say that this is a new function, not the same as my original function. Okay, our next parts show that two functions are inverses of each other. Okay, so this is the concept. What we want to do is we want to do a composition. So we're going to compose h with g, and we need to compose g with h. So we have to plug them both into both sides. And when I do that, I should get a single x as my answer. Okay, so I need to do a composition of taking this equation and plugging it in down there. And then I need to take my g equation and plug it into both places in my h. Okay, so these problems are very algebra intensive. Okay, there's a lot of algebra here, so make sure we're paying attention to the algebra, because the first step is calculus, everything else is algebra. Okay, so this is 4 over something plus 2, and that something is 4 minus 2x over x. Okay, so that's what I get when I plug my 4 minus 2x over x, my h function, in for x over here with g. Okay, so that's where I start. Now comes the hard part, is having to simplify this, showing all the work. I know it's supposed to be x in the end, but how do I get there? So hopefully you notice that I have a fraction plus a number. I can't add a fraction to a number unless I change this to also be a fraction. So if my denominator is x, that means I have to multiply both sides by x over x. because I need to have a denominator of x. Okay, so here's my 4 minus 2x over 4 plus, this is now 2x over x. Sorry, this is supposed to be an x down here. Me siento poquito. This is what my equation looks like now. I have changed my 2 to have the same denominator as my fraction. So 4 minus 2x over x plus 2x. What do I get when I combine my numerators? Well, I guess that's a good question. What is minus 2x plus 2x? 0, right? Minus 2x plus 2x is 0, so my denominator is just left with a 4 over x. Okay, I do 4 minus 2x plus 2x. A minus 2x and a plus 2x is now 0, so I just have my 4 left. Okay, and the next step is something you need to be aware of. I am dividing by a fraction. What is the equivalent to dividing by a fraction? Multiplying by the reciprocal. So when I now multiply by my reciprocal, notice what 4 divided by 4 is. That's just 1, and I have left x, which is exactly what I expect if two functions are inverses of each other. When I compose them, all that's left should be the x. Okay, now let's try it for this side. So I'm going to put my 4 over x plus 2 into both places where my x is. So I have an x in the numerator and I have an x in the denominator. So I replace both of them. If I had a third x, I would replace that there also. Okay, so now let's do all of the algebra. The hardest part of any upper division math course is the algebra. So once again, I have to do what with my 2 times? I'm going to distribute, right? 2 times 4 is what? Is 8. I only multiply on the top. I don't multiply to the denominator. Okay, so I have multiplied 4 times 2, because this is technically 2 over 1, so 2 times 4 are both numerators. 1 times x plus 2 is just x plus 2. So I multiply on top to get rid of my parentheses. Now I'm in that same boat. I have a number minus a fraction. So I have to change my number into a fraction that has the same denominator as my fraction. So I'm going to multiply both sides by, sorry, not both sides, but the top and bottom by x plus 2 over x plus 2. I am multiplying 4. Just the 4 gets multiplied. And when I do that, I now have 4x plus 8, right? Because I multiply into both of these over x plus 2 minus 8 over x plus 2, all divided by 4 over x plus 2. So now let's do our numerical addition. So I have 4x plus 8 minus 8. What is 4x plus 8 minus 8? Right, 4x. The 8 minus 8 becomes a 0. So let me come right down here. So this is now 4x over x plus 2 divided by 4 over x plus 2. So now I'm back in that same boat of having a fraction divided by a fraction. And what do I do instead of dividing a fraction by a fraction? multiply by the reciprocal, right? So this is the thing I'm going to reciprocate. What's the reciprocal of 4 over x plus 2? X plus 2 over 4. Okay, instead of dividing by a fraction, I multiply by the reciprocal. So now, what can we cancel out? The x plus 2 with the x plus 2 and the 4 with the 4, right? And I can cancel out because it's multiplication. I am multiplying by x plus 2. I am multiplying by 4. And the only thing that's left is x. Okay, so whenever we have these fractions as our beginning functions, right, there's a lot of algebra that is involved to show that they are inverses of each other. But the theory says if you compose them together, you should just get x as your answer. So at least we have an end goal of what our final product should look like. Okay, number 3. What type of a function do we have? X squared minus 4. This is called a quadratic. This is a quadratic. Okay, but we're only looking at positive values of x. Okay, so no negatives. So when we do our chart, we're going to start at 0, 0, 1, 2, and 3. Let's do that. If x is 0, what is y? What's 0 squared minus 4? Minus 4. And then we're going to plug in a 1. What's 1 squared minus 4? Negative 3. And then we're going to plug in a 2. What's 2 squared minus 4? 0. And then we plug in a 3. What's 3 squared minus 4? 5. Right, so these are your original functions. So let's come over here and let's plot those points on our graph. Okay, so there's our function y. Now, let's plot the inverse. So we do that by taking your x's and making them the new y values. So this is now 0, 1, 2, 3. Right, those are the y values for your inverse. And your original y's become the x's for your inverse. Okay, so that's how we make an inverse. You switch the x and the y. Okay, so we use our function to calculate your x and y values, and then you just flip them, right? You make the x the y and the y the x to do your other ones. So now let's plot these guys and see what our inverse graph looks like. So this is the graph of our inverse, right? And this one is the graph of our function. So notice, maybe you don't notice, but we should notice that our inverses are a reflection across the diagonal line y equals x. Okay, so this is your line of reflection for an inverse. It's a diagonal line. So if I folded my graph along my diagonal line, the inverse and the function would line up on each other. They would lap or overlap each other. Okay, that's also a true thing for inverses. So let's find the inverse of our function, x squared minus 4. So we find an inverse by switching your x's and your y's. So x equals y squared minus 4. Okay, so I'm finding the inverse function of my original. So first step is plus 4. So x plus 4 equals y squared. And our last step, square root both sides. So my function is the square root of x plus 4. Okay, so here's an understanding type of a problem. What kind of functions are not invertible? So maybe it's a vocabulary word. What does it mean to be invertible? That means that the inverse is also a function. If your function is invertible, then its inverse is also a function. Okay, so we just dealt with an equation that is usually not invertible. Right? What type of an equation did we deal with right here? A quadratic. Right? So if we look at the graph of a quadratic, what happens if I draw a horizontal line through it? It crosses it twice. Okay, which means that it's inverse, right? So the inverse of a quadratic is a sideways parabola, is not going to be a function because it will fail the vertical line test. So what kind of functions are not invertible? Those that fail the horizontal line test. So what do you have to do to make it invertible? You have to do some type of a domain restriction, just like we had on our previous problem. Right? Our previous problem said only take the positive values of x. Because if we didn't, we would not have an invertible function. Our inverse itself would not be a function. Okay, so that is a conceptual understanding that if you want to have a function be invertible and it's a quadratic, then you have to do something with its domain. Okay, one last thing about notation. If this is your f function, how do we find f inverse at 6? Well, one way is to create our f inverse function. If we want to find f inverse at 6, we need to know what is f inverse. Right? Makes perfectly good sense. If we want f inverse, we need to find f inverse. So how do we find an inverse? Well, you switch your x and your y and you solve for y. So x minus 4 equals 4y. So x minus 4 divided by 4 is your inverse function. X minus 4 divided by 4. So now, do I have a place to plug in 6? Yes, I'm going to plug 6 into x in my inverse function. So f inverse of 6 is 6 minus 4 divided by 4, which reduces to 1/2. Okay? So if you want to know what is the value of an inverse, you have to calculate the inverse. Okay? You don't plug 6 directly into your function, because this is not the inverse function. This is your original function. You have to plug 6 into the inverse. Okay? But what if it was too hard to find the inverse? Well, if it's an x in my inverse, that means this must be a y value for your original function. Okay? So that means you can plug y right here. 6 equals 4x plus 4. So if it's too hard for you to find the inverse function to plug it in, then you need to know this is a y value in your original function. In your inverse, it's an x, but in your original, it's a y. Because to find an inverse, you switch your x and your y. So this is a y value for my original function, and if you solve this for x, you get x equals 1/2, which is the same as when you solved it down here. Okay? So there's two ways that you can do that. The first way would be to actually calculate the inverse function and then plug your 6 into that, or to recognize that this is a y value from your original function and plug 6 in over here to solve. Okay, so there's a little bit more about inverses for you to study, right? Make your note card, maybe with something like 1 and 2 on it, because those are probably the ones that are the most difficult for you. All right, good luck, good brains. Have a great day.